A good day, same. I started by importing libraries, pandas, numpy, matplotlib, sparsy, which is a natural language processing library which provides functionalities like tokenization, part of speech tagging, and named entity recognition, which are crucial for analyzing text data. NLTK text blob, Vanda sentiment, which is specifically designed for to analyze sentiment in social media text, and it provides a quick way to gauge sentiment polarity, positive, negative, and neutral, which is valuable for understanding student feelings. And also Bay topic for topic modeling using transformer-based embeddings, Skyline, a machine learning library which provides tools for data processing, model training, and evaluation vital for any predictive modeling tasks. And also word cloud, which generates word clouds from text data. Plotly for creating interactive visualizations, and also sentence transformers provides models for generating sentence embeddings useful for measuring semantic similarities between student queries and suggesting resources. And I also imported transformers, a library for which allows access to pre-trained models for tasks such as text generation and classification. Moving on to my feature 1. So we have data fetch 20 news groups, remove headers, footers, and data 200. So this function retrieves a data set of news groups from 20 news group data sets. The remove parameter specifies that headers, footers, and codes should be excluded from the text data. And data 200, this slices the dataset to include only the first 200 posts for faster processing. And we have a Bay topic language English. It initializes a Bay topic model for topic modeling, specifying that the input language is English. And topics, it fits the model to the provided data and transforms it, retaining the unidentified topics and their respective probabilities. So I commented those they are just for visualization. You can comment these 2 lines if you want to visualize the topics directly. And figure hierarchy, this creates a hierarchical visualization of the topics, showing how they relate to one another, and displays the hierarchical visualization. Word cloud of topic retrieves the words associated with the most prominent topic and converts it to a dictionary where keys are words and values are their frequencies. And word cloud also initializes a word cloud object with a web background and specified dimensions, as you can see with the codes executed, and it generates a word cloud based on the frequencies of the words in the topic words dictionary. And we have our visualization. PLT figure creates a new figure with a size of 10 inches wide by 5 inches tall, and PLT I am sure displays the generated word cloud image. And PLT axis hides the axis for a clear representation of the word, and sets also the title for the plot. And we have PLT.show, which renders the plot. And if we run this code as we did, it loads 20 news group datasets and processes the first 200 entities, and then the topic model should identify topics. And you can see the hierarchical visualization of these topics. A word cloud for the most frequent words in the topic is also displayed. Moving on to my feature 2, which is a review analyzer that summarizes course feedback. The NLP technique used is text summarization using a summarization model, BET. So I see a sentiment intensity analyzer. This initializes a sentiment analysis tool from the Veda sentiment library, designed to ensure the sentiment of the text data specifically for social media informal communication. And also sentiment, it uses a list comprehension to iterate over each text in sample text, see polarity scores. For each text, it computes sentiment scores, retaining a dictionary with various scores: positive, negative, neutral, and compound. A compound extracts the compound scores, which is a single score representing the overall sentiment, ranging from -1, indicating very negative sentiment, to +1, indicating very positive sentiment. And then on visualization, we're creating a new figure for the histogram with a size of 8 inches wide by 4 inches, and etc. Histogram, the data being visualized. And As you can see, a sentiment analyzer will process first under text from the dataset, and then the code created a histogram displaying the distribution of the compound sentiment scores across the selected text. Moving on to feature 3, which is a filter for irrelevant or inappropriate posts, and the NLP technique used is semantic similarity and using sentence transformers to compute similarity. This initializes a summarization pipeline using the BET model from the Hugging Face Transformers library, and the Facebook BET large CNN model is specifically designed for summarization tasks, leveraging its pre-trained capabilities to generate coherent and concise summaries. So it concatenates the first 3 texts from the dataset into a single string, creating a long input text for summarization, and the method joins the text with the space generator. And it also calls summarization pipeline on a long text and specifies the maximum length of the generated summary, 60 tokens. It also specifies the minimum length of the generated summary to 30 tokens, and it indicates that the summary should be generated deterministically rather than randomly. The output is a list of summaries from which they extract the first summary text using summary _text, and we display the results.